Hello and welcome to my Pre-Algebra Big Ideas review series. This video covers Chapter 9, Section 4 of your Big Ideas textbook, titled Choosing a Data Display. How can you display data in a way that helps you to decide? You'll be able to answer this question by the end of this video. You will have reviewed recent lessons regarding data displays and their uses. You will be able to choose an appropriate data display for the situation and explain your reason for using it. You will be identifying the appropriate data display to match your data types. You will know how to identify a misleading data display and to analyze the misleading data. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It'll more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and I do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So let's do some math. So a key idea, data display types. So this is just showing a list of different types of data displays that you could use to visualize and interpret different types of data sets. So there's picture graphs or pictographs that show pictures shows data using pictures. Like here you see the A, B, C, and D, and we've got birds, so we're probably counting birds or types of birds or whatever, this could be orioles and robins and cardinals or whatever the letters could be. And it's the number you might see of them or that type of thing. You have a bar graph, which shows data in specific categories. A circle graph shows data as parts of a whole, like a whole year, 12 months, you could have 12 different sections. Okay. A line graph shows how data changes over time. You see it goes up or down or whatever. A histogram shows the frequency of data values in intervals of the same size. So from January to March and April to June or whatever. And then they can show you maybe the data in that group or the quantity. A histogram shows the frequencies of data in intervals of the same size. So once a year and the frequency of a type of data. Then there's the stem and leaf plot, which you don't get that often. We don't see those very often, which categorizes like elements, and within different groups, how many times do you see that item within that group type of boxes. There's box and whiskers used in a number of different areas, but it's used more in when you're talking about standard deviations and this type of thing. And then there's the dot plot, which shows the number of times each event occurs in a data set. So like here you could say from 1 to 12 of these lines across the bottom here, these lines going across the bottom, these lines here, how many times did something occur at that time or in that period or whatever. And then there's a scatter plot, which shows the relationship between two data sets by using ordered pairs. So it could be something in one direction and the other in the other direction. It's like a 5 of this and 4 of that, here's that point, and 4 of this and 2 of that, here's that point. And then you see the frequency of the data set combinations, okay? Whether they form lines or curves or they don't show any relationship at all. That's basically what you see with these different data types. And we're going to look at some of these data displays and see about using them in the future slides here. Okay, for example 1, choosing an appropriate data display. So this is choose the appropriate data display for the situation. Explain your reasoning. Okay. So for problem A or part A, the number of students in a marching band each year. What kind of display would we pick? How would we go through this and try to determine what type of a display we would use to pick that's correct for this type of data? Well, they're talking about the number of students, so that's a quantity, and it's over like each year. It could be each year, each week, each month, whatever the case is, but it happens to be over a period of a year at this point. So the appropriate thing would probably be to pick a display that shows you changes in something over a period of time. And if we look down here, the first one that comes to mind, a circle graph shows data as parts of a whole, and we're not looking at that, Here, a line graph says shows data change over time. So we're going to say that a line graph, right here, you see a line graph shows data change over time. So a line graph is an appropriate data display. Okay, because it goes up and down. There are other types of graphs that do the same types of thing, but this is a very good one for it. How about a comparison of people's shoe sizes to their height? Well, now we're going to compare two separate data sets, right? The people that have a size shoe 9 or a 9.5 or a 10 or whatever the size is, and how tall are they, right? So how tall are the people that have 9.5s, or how people are tall that have 11s or 7s or whatever the case is? How tall are they? And we can be able to plot that on a chart. Well, the best way to do that, if you look down here, you're going to find that it says down at the very bottom, a scatter chart shows the relationship between two data sets by using ordered pairs in the coordinate plane. So this is probably the best way. It says if you want to compare two different data sets, a scatter plot is the appropriate data display to use. Okay, carrying on with the same theme here. Now, for you to do this on your own, they're giving you two problems or two types of displays to pick. It says choose an appropriate data display for the situation. Explain your reasoning. So you go ahead and do it. I'll read it to you. The population of the United States divided into groups. So what could the groups be? It could be males versus females. Could be age, under 20, 20 to 25, 25 to 30. That's groups. How many people in each group? Could be something like that. And then the second question is the percent of students in your school who play baseball, basketball, soccer, football, lacrosse. So this is the numbers in categories, like, oh, you play basketball? Okay, you play, you don't play. Football, you do, you don't. 10 play football? Okay. So go ahead and do those. When you come back, we'll talk about answering them. Okay, now that you've had some time to do that. So for the first one, the population of the United States divided into groups. I would say that the best way to do that is if we look down this graph here, we're going to see that a histogram shows the frequency of data values. That's the population of people, the frequency of a person in an age group. So the frequency of data values in an interval. So from how many from the age of 20 to 25, how many people are there? That's groups categorized, right? In terms of the quantity of items within a certain group. And a good one for that is a histogram, because it shows the frequency of data values in intervals of the same size. So it could be every 5 years as an adult, starting at year 21 or 18 or whatever, okay? So we have the histogram for the population, and for the percent of students who play baseball, football, lacrosse, that one's probably going to be like a bar graph. And a bar graph shows data in specific categories. So football players, 300. Basketball players, 210. Soccer players, whatever the numbers are, I'm just making these up. But that's kind of the categories and the quantities. That's kind of what that's showing. So a bar graph shows data in specific categories, and these are specific. Soccer is specific. Lacrosse is specific. Okay? Okay, moving on to example 2, identifying an appropriate data display. So we're continuing with the same theme here. We're going to try to pick the right display. So we have this spiral notebook is our data that we're going to be looking at or thinking about on the far right. So it says, you record the number of hits for your school's new website for 5 months. August, September, October, November, and December. 5 months. Okay? Tell whether the data display is appropriate for representing how the number of hits changed over the 5-month period. So they want to know how did the hits change. In September, we had so many. In August, and in September we had a different amount. We want to know how much did they change? A lot, a little, right? So that's kind of, and then once you've done that, explain your reasoning. So we're going to look at this. The first question is, a bar graph shows the number of hits for 5 months. So yes, the bar graph is appropriate. Because we're seeing right down here, August, and we see there is 250 hits. September, we have 350, or whatever the numbers are, right? 320, we see them right here. Then 485 and 650. So it's showing you the change over time. So you see that the number of hits are going up. They're not telling you the percentage of change, but they're just telling you, you can see they are changing and going up. How about a histogram? Does it? A histogram does not show the number of hits for each month, or the number of hits has changed over time. It is not appropriate as a data display. So if you look at, here's the histogram, it says 0 to 399, 400 to 799, 800 to 1199, and 1200 to 1599. It's telling you the number of hits in total, but it doesn't tell you when they happened. It could have happened. All of these hits from 0 to 399 could have happened in October. We don't know when they happened. They're just showing you the number of hits for a period. That's the category and the number of hits in that category. How about a line graph? A line graph shows the number of hits for each of the 5 months over time. So it is an appropriate data display, because just like the bar graph up above here that kind of curves up and shows you the data is curving up, you see the same curve here on the bar graph. And you can see that each month the hits are going up. If all of a sudden the hits went down, you'd see the drop down too. You'd see that, we dropped off hits today or this month. But you can go back to the frequency, the histogram, looking. You can't tell what's up and what's down, when it happened. All you can tell is how many there were. So certainly a bar graph and a line graph is good for showing over periods of time, specific periods of time, the number of some quantity of something, number of shoes sold or gallons of milk wasted by farmers, or whatever the thing is. Okay, exercise 2 on your own goes, guess what? You're going to go and look at these yourself and try to come up with an answer for this. So it says directions. Tell whether the data display is appropriate for representing the data in example 2 and explain your reasoning. Well, the data in example 2, right here, I brought the chart forward with you, so it's this data right here, the same one we just used. The number of hits on a website over 5 months. So they want to know about, is a dot plot right? Is a circle graph right? Is a stem and leaf plot correct? So go ahead and work on that. When you come back, we'll do it together. Okay, now that you've taken time to do that, and you're back. So the first one is, how about a dot plot? Is a dot plot good to show the type of data we have, where 5 months of data collected for the hits on a website? Well, it says, would it show the number of hits over time? If we look at a dot plot shows the number of times each event occurred, but not the number of events over a specific set of time. So that's going to probably be no on the answer to this. So we're going to say no. Excuse me. How about a circle graph? Would a circle graph show the fraction or percent of hits for each month? Well, the circle graph, if we're going to do for 5 months, we could break this circle, shows data as parts of a whole. So if the whole survey was 5 months, the circle could say for the months from August to December, or whatever you could have that as the title of the chart. You could have 5 pie pieces in your circle graph, and you could show the size of each piece, larger or smaller, and what percentage of the circle it shows up. You could get a perspective. Okay? So I would say yes for that one. Y-E-S. Now how about a stem and leaf plot? With the stem and leaf plot, show how the number of hits change over time. Well, a stem and leaf is here, and it says orders numerical data and shows how they are distributed. So this tells you how they can put it in order, like shoe sizes, 8s, 8.5s, 9, 9.5, whatever, and then how they're being distributed by cities or where they're going, that type of thing. That's what a stem and leaf plot could show. So I would say they want to know how many hits over time. So you might be able to imagine that the time was months, and then you could say 1, 2, 3, 4 months. But I'm going to say that this is probably no on this one. It's not an appropriate. It wants to know if it's an appropriate display. Not that it could be made to work or tricked into working by changing the way you're thinking of the data. But is it appropriate? And the appropriate one for that we determined was a line graph. Was this line graph right here was the appropriate. And also, what was it? The bar graph was another appropriate one. We decided those were correct. So, for example 3, identifying misleading data display. It's not that the display is misleading, it's how they present the data in the display that can be misleading to how you interpret the data. So it says, let's read it here. It says, which graph is misleading? There's two graphs here. And look, when you first look at it, how do we know which one's misleading? Well, let's read down here and see what it says. First of all, before I do that, let's take a look. If you notice the graph itself, this shows a lot of movement. So let's assume that this is your pay. It looks like you had $9 in 2005. In 2006, you were getting 9.5 or whatever, 9.25, and it's going up. You went all the way up to maybe 12 or whatever this is up here, or 10.5. 10.5. And then it came down a little bit, but you're staying up here, right? Could be your pay. I don't know, over these years. Okay? But that looks like you had a big pay raise. Whoa, look at that. Bob here, he's getting a lot of pay raises. He's doing good. Well, on this chart below, it's the same data. 9.25 or whatever it is, 9.75, 10. It's the same data, but it doesn't look like, it looks kind of flat and boring and like, no, you're not getting much raise at all, are you? What's the same data? So why is it misleading? The thing that makes it misleading is you always have to look for this in graphs. It's what they're showing you in the columns. First of all, in the bottom graph, they're going from 0 up to 10 or 11. They're showing you every number in the graph. So there could be a $2 pay down here, $2. You don't see 2 here on the graph. You're seeing from 8 to 9 and 9 to 10 are way bigger spaces than down here. 8 to 9 and 9 to 10 is this area here. And up here, 9 to 10 is this big. Quite a bit larger. Oh, it goes down to 8 actually, excuse me. It goes down to 8. Look how far that changes. That's a very big change right there, compared to this smaller change right here. Well, it's the same data on 2 different graphs. And the way they get away with that is right here. You see this little squiggly line here, zigzag. Well, that's kind of saying that this is broken data. And it means that the date 0 is down here, and we don't know what happened on the data down here going from 0 to 8. But from 8 up, the data is correct. But all the data here, but from 0 to 8, is we're not going to make any judgments on what the value of that is. So by doing that, it shrinks the chart. It enlarges the data items in the chart. The distance between 9 and 10 is much greater than it is from 9 to 10 on the bottom chart. So it makes it appear bigger. That's why it's misleading. I'm going to read this to you. It says, the vertical axis of the line graph on the top has a break shown as a zigzag line between 0 and 8. This implies a disruption in the amount of data being displayed. This gives the data in the graph it appears to be more significant or to be larger than it truly is, and therefore makes the data from 2005 through 2009 appear to have increased much more. Wow, you got a lot of big pay raises, didn't you? But in the bottom graph, it says the graph on the bottom without the zigzag line shows the data and the true data, and therefore the revenue has increased more slowly. If you really look at it, you say, wow, your pay hasn't really increased as fast as it looked like it had. So the data in the graph on the top is misleading. And that's what we're trying to get that thought going here. When you look at data in a graph or chart, you need to determine that, does this appear bigger than it really truly is, or to make me feel, oh, wow, I got to go do something, to stimulate your interest in something. Okay, again, now in example 4, we're analyzing more misleading data. Okay, it's not the display that's misleading, it's the data in the display and the way they configured it that makes it misleading. So, this is very similar to the one we just looked at. A volunteer concludes that the numbers of cans of food and boxes of food donated were about the same. Is this conclusion accurate? Well, let's look at it. Well, we look at this chart here. We say, oh, look at the nice chart. We've got, oh, the canned food goes over all the way over to here. Yep, it goes out to whatever that point is. And look at the box food. Oh, goes almost out to the same point. Yeah, they're about the same. We had this orange juice. It's way back here. It's not doing anything. But the canned food and the cereal looks like it's almost as, when you first glance at it, it appears that, oh, yeah, they're about the same. The number of donations of cans of food versus boxes of cereal. But if you look at it more closely, you'll see each icon represents the same number of items. So if 20 cans, down here the chart says 20 cans is by, this little can means 20 cans. This box means 20 boxes, and the bottle means 20 bottles. So it's the same one. But guess what? If you look at the chart, I'll continue reading. It looks like the number of the boxes is about the same as the number of cans. That's what I said. But the number of boxes is about half of the number of cans. So let's look at it. It's 1, 2, 3, 4, 5, 6. So 6 times 20, right, is 120. But there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times 20 is a bigger number, right? It's 220. So you can see that it is misleading. The juice on the bottom is actually more accurate, because if you compare 3 cans, it's not truly accurate, but it's more accurate because 3 cans of canned food almost equals to 2.5 bottles. You see, so actually there's less juice, but they're making it look like it's actually more, maybe a little more juice. It's hard to say, but so no, the conclusion is this is not an accurate display. Okay, exercise 3, on your own. Explain why the data displays are misleading. So go ahead and take your time and let you think about it. Stop the video. When you come back, we'll talk. Okay, I'm assuming you've had time to stop it, think about it, and come back. So, explain why the data display is misleading. So for number 6, it shows the concert ticket prices in dollars and a band, the rock band, band A, band B, and band C. So if you look at these, what makes this misleading? First of all, the $40 tickets for band A are down here with little teeny tickets, little short, little skinny tickets. For band B, rock band B, it's $5 more. But look at this. The tickets look way huger, and they're way, like, oh, these are way more expensive than band A. Oh, if I'm going to buy these tickets, well, I can maybe afford band A tickets, but not band B, because look, they're so much bigger. And band C, you get way up here for $53 or whatever it is way up here. Look how huge these tickets are and how fat the tickets are. So this is really the most expensive band. So there's no way, to me, if I'm going to look at them and say, I can maybe afford this, but there's no way I could afford these tickets for band C. But if you put it in perspective, they're only $15, and that's, I know it's a lot of money, $12 or $13. It's a lot of money, but it's still not as big as this chart makes it appear to be. Okay? And then if we go to this number 7 here, it's profit, billions of dollars in profit, billions. Each the height of these stands for billions. So it's 10 billion, 15 billion, 20 billion. As you go up, 20 billion, 15 billion. So over years 1, 2, 3, 4, and 5. So let's look at the revenue. So how much did the revenue increase? Well, the revenue increased from 10 billion over 5 years to, let's say 14. So it increased $4 billion. Okay, $4 billion. However, guess what? This it looks like, because this block here is way fatter than the one in front of it, and fatter, and it keeps going down. So if the early block is way a little skinny one way down here, it makes it appear, if you don't really pay close attention to the numbers, it makes it look like, wow, you got a lot of money, extra money you made in the year 5 based on 4 years ago. You see what I'm saying? Or 5 years ago. So this is a solid chart. They didn't break the data at the bottom, but they tricked you by what the picture shows. It's like the boxes of food and the cans of food in the previous display. Here in the first one, in 6, I didn't mention it, but they did do a squiggly line, right? A little zigzag. That's saying that a lot of the ticket is down here, not even showing all from 0 to 35. That's all, it'll be way down here somewhere if they got way down there. Maybe not that far, but makes you see that the price change of the tickets isn't as big as they're making it to be. Okay? So on 7, the bars get wider. The data is correct, but the bars get wider, makes you think there's a greater revenue. And for the ticket prices, the tickets get bigger, way bigger, but when they're not really, shouldn't be big, fatter. And they should be way longer if they're going to match all the data.